So our video here is just going to do a couple minutes of work to solidify the key concept background behind the two key equations that we're going to work with when it comes to radians and measuring different components of a circle, namely arc length and the area of a sector of a circle created by us traveling along an arc. So recall, when we travel around one revolution around a circle, we'd start here. I'll go ahead and just kind of draw my XY scale. If we took one full revolution around that circle, we've traveled an arc length that is consistent and is equal to the circumference of that circle, which is 2 pi r. And by the way, if we were to shade in this whole thing, that sector that we traveled, we covered the entire area of the circle, known as just our great old formula of pi r squared. Now remember, we've said that radian measure is nothing more than what? It's a ratio of our arc length to the radius of our circle. So when we travel an arc length of 2 pi r, the ratio of our arc length to the radius is nothing more than 2 pi r over r, or 2 pi. And that's why we said a full revolution is equal to 2 pi radians. Now what that also means is when we've traveled a full revolution, well, there's a nice relationship that we can do. We'll talk about that in a second. Since theta equals 2 pi, it's what we've seen here in a full revolution, what's it also tell us? Well, if I just do a little bit of quick algebra, it tells me that the value of pi is nothing more than theta over 2 in this case. So look at what this means. It means that, remember, our area of the circle is nothing more than pi r squared. That's what we've always said. What did we just say in this case? What do we know that we can substitute pi as? Theta over 2. Area of circle, area of sector, is nothing more than the angle, theta over 2. That's the same as pi now. Theta over 2, r squared, or the good old formula 1/2 r squared theta that you see right here. Now, let's just kind of take that to a different level, and let's just consider an arc that's built when we go on a semicircle. If you travel a semicircle, there's our length, arc length. Well, it's half the circumference this time. So what's the angle? Well, let's first figure out our arc length one more time. It's nothing more than pi r. It's 1/2 of the circumference of the circle, half of 2 pi r. What's that tell us? What's our angle theta? Well, we should already know this, that when we do a semicircle, the radian measure is pi radians. And so for a full semicircle, we have theta equals pi. It's a perfect mapping of the two pieces to each other. So the purple shaded area that you see right up here represents the area of the semicircle, which, hope you would agree, is 1/2 pi r squared. Well, in a semicircle, what's the nice relationship that walks right into us? Theta equals pi. So what's that tell us? Well, 1/2 pi r squared. If theta and pi are the same thing, it means 1/2 pi r squared is nothing more than 1/2 theta r squared. And so this is the gist of where these two key formulas come out. Some very, very basic and simple algebra. Go through this a few times. Don't be afraid to look at it. Remember the key relationship. Theta equals 2 pi. Theta equals pi. Theta pi radians. Theta 2 pi radians. 2 pi radians full circle. Semicircle pi radians. And if you see these pieces, those two formulas should work very, very nicely for you.